Hi everybody, welcome to another video in Statistics, Chapter 7, Normal Probability Distribution. Before we get to normal distribution, we look at the fundamental probability distribution, the uniform probability distribution, just to get the idea of what is the probability distribution will look like for continuous random variable. So, probability density function PDF is the equation used to compute the probability of a continuous random variable. So now we focus on continuous random variable. It must satisfy the following two things: the total area under the graph, the equation over all the possible values of the random variable must be equal to 1. So the total area is equal to 1. And the height of the graph of the equation must be greater than or equal to 0 for all possible random variable. Right, so greater than or equal to 0 for the height of the graph. Right, let's look at this, what we call the uniform probability distribution. Suppose the UPS is supposed to deliver a packet from 10 to 11. So all it is from 10 to 11. Anytime from 10 to 11. So it is continuous variable. Let the random variable x represent the time from 10 when the delivery take place. So if we let x equal to 0, then will be 10 a.m. X equal to 60, that will be 11 a.m. 1 minute interval. That is to say the package is likely arrive between 10:15 and 10:16, and it is 10:40 to 10:41. So it is random from 10 to 11, and it is equally likely the package will arrive at any of those times. Because of the any two interval of the length between are equally random, is follow the uniform distribution. Right, so we have this graph, x equal to 0 to x equal to 60, so 60-minute interval, and the height is 1 over 60. So for example, if it is arrived at 10:15 to 10:16, then we have the area for that particular. Let's say we have from 10:15 about here to 10:16. Then we take the width of 1 minute from 15 to 16. The height is 1 over 60. So we calculate that area over the total area. Will give us the probability. By the way, the total area is 60 on the right. The width, the height is 1 over 60. 60 times 1 over 60 is 1. So the total area is 1. And if we want some certain interval, then we just find the area of that, and then divide by the whole thing. Right. Here. Find the probability that the package arrive at 10:15. So from 15-minute mark to 30-minute mark. So we look at this. If we want to find the probability here, we find the volume. I mean the area from 15 to 30. So we have 15. The width is 15. The height is 1 over 16. 1 over 60. So we have 15 over 60 is 1 over 4, or 25%. Right? So we just find the area of the corresponding interval from x from 15 to 30. So we said probability that x will be between 30, from 15 to 30 is equal to the width times the height, and that will be just that. Now next, find the package that arrived before 10:45. So 10:45 is here, and it is before that, so anything here So we write the probability that the package arrived before, so less than or equal to 45, will be the width times the height. So we have 45 over 60, 3/4 or 75%. Right. So it's just simple example just to show that how the area will work in relate to probability. So how probability and area are related. So the total area is 1, and the area of certain portion will be corresponding to the probability for the random variable between the values, corresponding values. Right. Now more important, the normal probability distribution. So definition: relative frequency histogram that are symmetric and bell-shaped are said to have a shape of the normal curve. So a normal curve is like a bell shape. A continuous random variable is normally distributed or has the normal probability distribution if its relative frequency histogram is random variable has the shape of the normal curve. So this is the shape of the normal curve. So the properties: it is symmetric about the mean, so the mean will be right in the middle. And the mean, the mode, the median will be at the same, so that would be the highest point. The inflection point is at mu plus 1 standard deviation. So 1 standard deviation away we have the inflection point. The inflection point is where it kind of, I mean, it is increasing on this side, but kind of open up. This is open down. So if I try to, so this kind of open up, and this is open down. Inflection point is kind of right there. So 1 standard deviation away we have the inflection point. The total area under the curve is 1. So even though this will go to indefinite, go to infinity, but the total area is 1. And the area on the right side, on the left side of the mean is exactly 1/2. Yeah. So the line gets closer and closer to 0, but we never touch. And finally, the empirical rule, we said within 1 standard deviation is 68%, within 2 standard deviation is 95%, and within 3 standard deviation 99.7%. We talk about that. But now we said, what happens if we have kind of right anywhere here? Then what will be the area, or what will be the probability? Right. So let's look at area under the normal curve. Suppose that the random variable x is normally distributed with the mean and standard deviation. So for normal distribution, we need to know the mean and standard deviation, sigma. The area under the normal curve for any interval of values of random variable x represent either the proportion of the population with the characteristic described by the interval of the values. So the area can be interpreted as a proportion of the population that has some certain characteristic. Another interpretation is the probability that the random select individual from the population will have the characteristic described. So this is the probability that a random selected individual will have some certain probability, certain distribute. All right, we'll see that in the next example. The weight of giraffes are approximately normally distributed with the mean of 2200 pounds and standard deviation of 200 pounds. I'll draw the normal curve with the parameters labeled, right? So usually I just draw a line. and then don't try to make it symmetry. The line first, just draw the line after we draw the curve. So the curve to try to make it as symmetry as possible. After that, we will kind of divide that in half. And we have the mean, which is at 2,200 pounds. And after that, we find the inflection point where it's between open up and open down. So this around here. And try to make it as symmetry as possible. So that's distance about 200, and that is standard deviation. So right, so that should be a mu plus 1 standard deviation. So 1 standard deviation on the left and 1 standard deviation from the right. And so that's 200. So plus 200 is 2,400 pounds and 2,100 pounds. Right, so we have that. The shape of the normal curve with the mean and standard deviation of 200. Now, I will draw a normal curve. After that, say the area on the normal curve to the left. Of 2,200. I just say that on the left, so it's easy to see. So it's on the left of 2,200. So we talk about this one. And on the left of the mean, the area of that is 1/2, because this is symmetric. So 1/2, it is just half of it, or 50%. Now, the next one, find the area. Of course, the area is 50%. Provide 2 interpretation of the result. So the interpretation is 2. Number 1, we said 50% of the giraffe, because the population here is the giraffe. Weight 2,200 pounds or more, because that on the, oh wait, sorry, we say on the left. Okay, so not that, we talk about the area on the left. Sorry. Yeah. So good thing is, it's on the left, the area is still 50%. And we say 50% of the giraffe will weigh 2,200 pounds or less, because that's on the left. Right, and then next. So we talk about the proportion of the population. The other interpretation, we said if we select one giraffe randomly, is selected randomly, there's 50% chance, the probability that its weight is 2,200 pounds or less. It's 50%. So we have the area is 50%, and that also the proportion of the population less than the mean 2200 pounds. And I would say if we select one giraffe randomly, the probability that it weight is 2200 pounds or less is 50%. So the probability, area, and the proportion of the population will be the same, meaning the analytic score on a standardized aptitude test are known to be normally distributed with the mean of 610 and standard deviation of 110. Draw a normal curve with the parameter label. So try to draw the curve again. Just going to use pencil here. Try to make it symmetric. Right. So the mean is 610. The standard deviation is 110 away from it. So if we add a standard deviation, 610 plus 110, that's 720, and subtract one standard deviation, that will be 500. Right. Shade the region and the area that represent the proportion of the test taker who score less than 7200. So less than 7200 will be this. And of course this one as well. And then shade the region. Now we find the area. First of all, on the left side of 610, that in the mean, so that will be 50%, right? So the area, if we talk about this part, that area is 50%, so 0.5. And empirical rule said from the mean to one standard deviation away from it, it is 13%. Sorry, 13.5%. I'm sorry. Okay. That's what we need to chart. Right, look at this. From the mean to one standard deviation away from it, that's 34%. So from the mean to one standard deviation away from it, so that's 34%. When we add, we have 0.84%. So 0.84, which means 84% of the population, meaning 84% of the test taker score 72. Let me say it again. 84% of the population is test takers. So 84% of the population score less than 720. Or we say if we select one random test taker, the chance for that test taker score 720 or less is 84%. Notice that this is continuous. So when we said less than or equal to or less than 720, so that is almost the same thing because it is continuous. Right. So once again, the area meaning three things: the area itself, the proportion of the population, and then the probability of selecting one random individual. We have that characteristic. Right. With that, I'll stop the video here. It's just a quick introduction for the normal distribution. We'll study more about the normal distribution in the next section. Thank you for watching.